microcontrollers, that is embedded processor families. See, we know that we have discussed about the microprocessor based system. Then we have briefly discussed about microcontroller. Then what is the difference between a microprocessor and a microcontroller? See, in the microprocessor, we were integrating our RAM, ROM, input-output port, a timer or a counter, serial port, everything there. Many chips were there on the motherboard. We were adding to the CPU. That is a general purpose microprocessor system. But in a microcontroller, all these individual units were integrated into a single chip. And examples were our 8051 family, then our Motorola's 6811 family. Let us see briefly what is the difference between a microprocessor and a microcontroller. See, as we have already told, microprocessor is a standalone RAM, ROM, input, output, timer, etc. And it is not a pre-programmed. That is, since it is a general purpose, the programmer is free to design it when it is needed. But in the case of a microcontroller, it is pre-programmed, and it is actually used for a special purpose or a single purpose. For example, a washing machine, it is used only for a single purpose. So it's not a general purpose. Microcontrollers are they are not general purpose. They are special or a single purpose devices. Now let us discuss about the embedded processor families. See, we know that many of these embedded applications are like our set-top box in a television or a washing machine or a digital camera. They don't require a powerful processor because they don't need much computational requirements. For such applications, it is preferable to use a chip rather than a simple processor, but which can contain sufficient memory resources. So that this is the only chip needed to implement all the controller functions. See, the processors may be characterized by how many data bits they can handle in parallel when accessing data in the memory. And the most powerful microcontrollers, they can have 32-bit processor with a 32-bit wide data bus that we are going to discuss in advanced RISC machines, that is ARM architecture. And also it is possible to have a 32-bit internal bus structure with a 16-bit wide data bus memory coming in the Motorola's 683XX family of microcontrollers. And see, such devices are classified as 16-bit microcontrollers, and they are the most popular microcontrollers are 8-bit chips. They are much cheaper. Now let us start our discussion with our 8051 microcontroller. In the early 1980s, there is Intel Corporation, they introduced the microcontroller chip that is called as 8051. This chip has a basic architecture of Intel's 8080 microprocessor family. This was using an 8-bit general purpose computing applications. And 8051, they have become one of the most widely used chips in practice. They were having four 8-bit input-output ports, then two 16-bit counter timer circuits, but they were having 4 kilobyte internal ROM and 128 bytes internal RAM. And if a EEPROM was integrated to it, they were having 4 kilobytes of EEPROM, then their version was 8751. See, number of various enhancements were provided for this 8051. And for example, 8052, they were chips, they were having 8 kilobytes of internal ROM and 256 bytes of RAM rather than 4 kilobytes of ROM and 128 bytes of RAM in 8051 architecture. And when EEPROM was integrated to them, their version was 8752. They were known as 8052. See, this microcontrollers chip, they were fabricated using NMOS or CMOS technology. That is, CMOS devices were having advantages of consuming less power. And 8051 architecture was developed by Intel, as we have told. And they were having higher degree of availability of the chips and at a competitive prices. Let us see just a brief introduction about the general block diagram of our 8051. As we know, the microcontrollers, they were having a CPU along with them the ROM or the code memory as we call, and the runtime memory, that is a RAM 128 bits bytes. Then the serial interface was also there, an oscillator which was also an interrupt controls and four input output ports along with the best control. They were provided in the general block diagram of the microcontroller of 8051, and these are the main devices that are integrated on the chip of the microcontroller 8051. See, coming to the pin description of 8051, it is a 40 pins dedicated for various purposes. They were coming in different packages like dual in line package, a quad flat, and also a dateless chip carrier. But some of the companies were also providing 20 pin version. Now coming to our Motorola microcontrollers, that is Intel and Motorola, they were having the dominant positions as manufacturers of microprocessor chips in 1980s. And their most popular 8-bit microprocessors, they became the basis for their microcontrollers. So coming to a 688C11 microcontroller, that is a Motorola's very most popular the 8-bit processors. They were having in the series 6800 and 6809. The microcontroller chip that implements instructions, they were having the superset of 6800 instructions. They were known as 688C11 microcontroller. They were having 5 input-output ports that can be used for various purposes. They were having a CISC microcontroller, which was having a low power consumption and a high performance operation. They were having a 48-pin dual inline package with the 38 pins were available for input-output functions. Also, 52-pin plastic leaded chip carrier, that is PLCC. They were known as LED card package. They were having one UART, that is Universal Asynchronous Serial Communication Interfaces. They were having stop and wait modes, and we need to just note the general output, what introduction of each controllers. The synchronous interface implements a scheme known as serial peripheral interface, that is SPI. That's possible to connect 8 analog inputs to 688C11 because of its capability to perform analog to digital conversions. As we know, as we have already told, the amount of memory, that is, it was having 8 kilobytes of ROM and 512 E square PROM or EPROM and 256 bytes of RAM in the original chip. And to that, a 12 kilobyte ROM and a 512 EPROM and a 512 byte RAM is also, there is a most advanced chips we were having, and its CPU features were also having a set of registers like CPU registers and input-output registers. It was having also 8-bit accumulators A and B. They were working as a general purpose registers. Also, they were having a stack pointer and 8-bit processor and 16-bit instructions like add, sub, rotate, etc. They were having port A, port B, port C, port D, and port E, 5 ports chips for input-output operations. They are having 21 independent interrupts, and among them 6 were non-maskable and 15 are maskable. And the high priority interrupts were reset, HIRQ, and IRQ. They were having operating modes, 4 of the operating modes like single chip, expanded mode, bootstrap, and test mode. Bootstrap mode, they were used to load programs into RAM. Each of these modes are having different functions that is mentioned here. Then there is a 683XX microcontrollers. They were also based on 68000 processor. They were including both parallel and serial ports, counter timer capability, and A to D conversion circuits. The amount of on-chip memory depends on particular chip. For example, 68376 having 8 byte kilobyte of E square PROM or EEPROM with a 4 bytes RAM, that is 68366 microcontrollers. They were also sometimes they were coming in the free scale. Okay, now next is our cold-fired microcontroller. They were having a pipeline structure. They were implementing 32 bus. They could implement a 32-bit bus. That is a full 32-bit bus. That see this Coldfire processor core is also intended for the use in a system on a chip environment. So they were having many distinguishing features which leads to enhanced performance. Next is our PowerPC microcontrollers. PowerPC means performance optimization with enhanced risk performance computing. They were sometimes abbreviated as PPC also. See, the Motorola's high-end microprocessor, they were known as PowerPC. They were based on RISC style architecture. This processor architecture is also available in the microcontroller form in chips compressing MPC5XX family. Okay, they were created by 1991. They were created by Apple, IBM, Motorola Alliance. They are also known as AIM. Next is our ARM or the ARM microcontroller, that is Advanced RISC Machine. That is an attractive for embedded systems which were having or which needed substantial computing capability, and its cost and power consumption is relatively low or less. This is also designed for suitable for a system on a chip environment. There are also these ARM microcontrollers. They are also available as separate chips. There have been a progression of ARM processor cores intended for embedded applications including ARM6, ARM7, ARM9, ARM10, etc. The basic ARM architecture is 32-bit organization. It was having an instruction set in which all the instructions were 32 bits long. And there exists also another version known as thumb, THUMB, thumb. It was also using a 16-bit instruction and a 16-bit data transfers, but it was a subset of ARM instructions which was encoded to fit into a 16-bit format. Only that much is there. So advantages it is having, it is significantly smaller memory is only needed to store the programs, comprising of highly encoded 16-bit instructions. A thumb aware ARM core contains a thumb decompressor in addition to its normal circuits. And this ARM architecture and its processor, respective processor cores, they were developed by the ARM RISC Machines Limited, and some of the companies like Samsung Semiconductor market microcontroller chips and all. They were they marketed microcontroller chips based on ARM cores. And now this is a simple ARM features, ARM advanced RISC machine feature. As we told, it was a ECD to had a pipelining structure with a EC decoding, and they were fixed 32-bit instructions. ARM architecture, they were also having an ALU, that is arithmetic logic unit, control unit, and a register file. And the first processor was developed in the year 1978 by the Cambridge University. And this is the some of the simple or the this 8051 microcontroller, then Motorola series, then ARM microcontroller. These were some of them. They were coming under embedded processor families.